Hey everyone, Mr. Houck here. In today's video, we're going to be looking at our quiz review to prepare for Thursday's quiz on Unit 1A. Alright, let's go ahead and get started. In problem number 1 here, we want to determine which ratio or ratios below are incorrect for the image provided. We want to select all that apply, so that means it's possible there could be more than one answer that is incorrect, or more than one ratio that's incorrect. The first thing we need to do, if we look at our image here, is we don't know the hypotenuse. And for some of our trig ratios, we're going to need to know the hypotenuse. Let's go ahead and discover that real quick. Using Pythagorean's theorem, 7 squared plus 24 squared will equal, we'll call the hypotenuse x squared. So using a calculator, that would give us 49 plus, and then 24 squared will give us 576 equals x squared. So x squared equals 625. And if we take the square root of 625, we're going to get x equals 25. Okay, so x is equal to 25. That's our hypotenuse. Now let's look at all of our trig ratios. Answer choice A says that the sine of theta is 24 over 25. Well, looking from theta, 24 is the opposite, and the hypotenuse is 25, so the sine is the opposite over the hypotenuse, so A would be correct, but we want the answers that are incorrect. So I'm just going to put a little check mark here. So A is a correct ratio. Now let's look at the cosine of theta. Well, the cosine of theta is the adjacent leg divided by the hypotenuse. Well, relative to the angle theta, 7 is adjacent, and 25 is the hypotenuse, so we want the ratio 7 over 25, which is what we have. So 7 over 25 is also correct. Looking at the tangent of theta, we know that the tangent of an angle is the opposite leg divided by the adjacent leg. So relative to theta, 24 is opposite, 7 is adjacent. So we should have the ratio 24 over 7, but notice that this gives us the ratio 7 over 24. So we know that C is incorrect. Continuing with the problem, the cosecant of theta, well, that's going to be 1 over the sine, or the reciprocal of sine. Since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Well, hypotenuse would be 25, opposite would be 24. Again, this is relative to the angle theta, so 25 over 24 is correct. Looking at the secant of theta, we know that the secant of theta is the reciprocal of the cosine, and since the cosine is the adjacent over the hypotenuse, the secant of theta should be the hypotenuse over the adjacent. So relative to theta, the hypotenuse is 25, the adjacent is 7, so 25 over 7 is a correct ratio. And then lastly, the cotangent of theta. Since the cotangent is the reciprocal of the tangent, we should have the, with the tangent being opposite over adjacent, the cotangent would be adjacent over opposite, which would be 7 over 24. That is not what we have here, so this is another one of our incorrect ratios. All right. Number 2 is a very similar problem. We're going to work through this one a little bit more quickly, but this time we're selecting all the ratios that are correct. So once again, we need to go ahead and figure out what our hypotenuse is going to be. Notice that this time we are missing a leg, and we don't need to find the hypotenuse, we need to find a leg because we have the hypotenuse and we're missing a leg. Misspoke there. So let's go ahead and use Pythagorean's theorem. 5 squared plus x squared equals 9 squared. So this tells us that x squared is going to be equal to 81 minus 25. 81 minus 25, that's going to be the square root of 56. So, 56. Then we take the square root of both sides, so x is equal to the square root of 56. And doing a little bit of work on the number 56, well, we know that 56 is 4 times 14. And we know that 4 is a perfect square. So x would be equal to 2 square root of 14. Okay, 2 square root of 14 is that leg. So let's go ahead and figure out these ratios here. So the sine of theta should be the opposite over the hypotenuse. Well, relative to theta, let's go ahead and label these just so we don't have to keep referencing them. So relative to theta, here's our opposite leg, 2 root 14. 5 is our adjacent leg, and 9 is the hypotenuse. So let's see if these ratios are set up correctly. So the sine of theta, we're saying is 2 root 14 over 9, well, opposite over hypotenuse would be 2 root 14 over 9, and that can't be simplified any further, so that is correct. The cosine of theta is going to be the adjacent over the hypotenuse, which is 5 over 9. That cannot reduce any further, so that is correct. The tangent of theta should be the opposite over the adjacent, which is 2 root 14 over 5, so that is correct, and that cannot reduce any further. The cosecant of theta should be the reciprocal of the sine of theta, so we're looking at hypotenuse over opposite, so that would give us 9 over 2 root 14. Now, at first glance, you might say, well, that's not the same thing. However, because of the square root in the denominator, we need to rationalize. So let's multiply both the numerator and the denominator by the square root of 14. This is going to give us 9 square root of 14 divided by 28, which is what we have here, so this is also correct. And also notice that that cannot reduce any further. For the secant of theta, we know that the secant of theta is 1 over the cosine of theta, or the reciprocal of the cosine of theta, which should be, instead of adjacent over hypotenuse, hypotenuse over adjacent. So that is correct. And then lastly, the cotangent of theta should be the reciprocal of the tangent of theta. So instead of opposite over adjacent, we're looking at adjacent over opposite, which would be 5 over 2 root 14. Once again, we don't want that square root in the denominator, so let's multiply both the numerator and denominator by the square root of 14. And this will give us 5 square root of 14 over 28. So it actually turns out that every single one of these answers was correct for that image provided. Looking at number 3, we want to find the exact value of x. So looking at this image and looking at the 45-degree angle, x is the leg opposite of the 45-degree angle. Also notice that the 11 that we're given here is the adjacent leg to the 45-degree angle because y is the hypotenuse. So I'm going to go ahead and set up the tangent. This is telling me to say that the tangent of 45 degrees is equal to x over 11, opposite over adjacent, multiplying both sides by 11. So I'll show that in gray here. So multiplying both sides by 11, we're going to get that x is equal to 11 times the tangent of 45 degrees. And plugging that into a calculator real quick, that will give us 11 exactly. Okay. Moving on to number 4, we want to find the exact value of y. So notice the same image, but this time we're finding y. So again, we know that this 11 that I'm highlighting in red is the adjacent leg, and y this time is the hypotenuse. So I'm going to use the cosine. I'm going to say that the cosine of 45 degrees is equal to the adjacent leg 11 divided by y. Multiplying y on both sides, I'm going to get that y cosine of 45 degrees is equal to 11. And then let's go ahead and divide both sides by the cosine of 45 degrees so that we can isolate for y. And this is going to tell us that y is equal to, and let's go and plug that in, 11 divided by the cosine of 45 degrees, 11 square root of 2. Which is answer choice B. All right, looking at number 5 here. For the triangle provided, find the measure of angle B in degrees. So relative to angle B, we have the opposite leg 7 and the hypotenuse 13. So opposite and hypotenuse, that's telling us that we should take the sine of the angle. I'm going to go ahead and call the angle x. Doesn't really matter. Right, let's call it theta. We normally call it theta. So let's call it angle B theta. So the sine of theta would be equal to the opposite leg 7 divided by hypotenuse 13. And recall that anytime we are solving for an angle, we need to take the inverse of that trig ratio. So we're going to do the sine, we're going to take the inverse sine of both sides. So taking the inverse sine at the left, all we would have remaining is theta, and then taking the inverse sine on the right side of the equation, let's see what we would get. So sine inverse of 7/13 will give us approximately 32.6 degrees. And we're making sure to round to 1 decimal place. All right, looking at problem 6, Deadpool needs to save a cat from a tree. He leans a 16-foot ladder against the tree with an angle of elevation of 80 degrees. How high up is the cat in the tree? Hint, draw a picture. So let's do that. Let's draw a picture. Here's our tree. Here's our ladder. Notice that we are making a 90-degree angle. And we know that the ladder is 16 feet long, so I'm going to go ahead and make this picture, make it actually look like a ladder. So our hypotenuse is 16 feet. We know the angle of elevation is 80 degrees. And we want to find the height, or how high up the cat is in the tree. I'm going to go ahead and label that x. So relative to the 80 degrees, we have the opposite leg x, and we have the hypotenuse 16. Opposite and hypotenuse indicates that we should use the sine. So the sine of 80 degrees is equal to the opposite leg x divided by 16. Let's multiply both sides by 16. And that's going to tell us that x is equal to 16 sine of 80 degrees. And let's go ahead and calculate that. 16 sine, 80 degrees in the calculator. And that's going to be about 15.8 or 15.76 feet, which is answer choice C. All right, number 7, convert 240 degrees into radians. So we know that 1 degree is equal to pi over 180 radians. So that means that we're going to take this 240 degrees and multiply it by pi over 180. So 240 times pi is just 240 pi. Let's go ahead and reduce 240 divided by 180. And that would give us 4/3. So this converts to 4 pi over 3 radians, which is answer choice A. Number 8, pretty quick question. True or false, both degrees and radians are measures of angles. This question is on the review because I really want to drive home the point that this is true. Degrees and radians are both measures of angles, okay? A lot of students are having a hard time understanding that, degrees and radians both measure angles. So 2 different measurements of angles, that's why we're able to convert back and forth between the 2. In problem 9, which of the statements below is not true? So 140 degrees converts to 7 pi over 9 radians. 335 degrees converts to 65 pi over 36 radians, so on and so forth. Just to save us a little bit of time and so that this video isn't excessively long, I'm going to go ahead and tell you that B is the not true conversion, and let's see why B is not true. If I take 335 degrees, and again, we're going to use our conversion that 1 degree is equal to pi over 180 radians. So I'm going to multiply 335 degrees, or 335 times pi over 180. This is going to give us 335 pi over 180. And simplifying the 335 over 180, that would give us 67 pi over 36. And this is not true because option B says it converts to 65 pi over 36 instead of 67 pi over 36. So A would be true if you work it out. C, D, and E are also true if we work them out. B, however, is incorrect. Number 10, select all the angles below that are coterminal angles of 280 degrees. So let's recall what a coterminal angle is. A coterminal angle is an angle that shares the same initial side and terminal side with another angle. Those are coterminal angles. And the way that we find coterminal angles is we add or subtract multiples of 360 degrees or multiples of 2 pi radians. So we're working in degrees, and essentially what we want to do is we want to add or subtract multiples of 360 degrees to 280 degrees. So let's go ahead and start adding multiples of 360 degrees. So if I add 360 degrees to 280 degrees, that's going to give me 640 degrees. Okay, well that's right there, so let's go ahead and circle that one. But again, this is a select all of the angles, so let's add 360 degrees again. We're going to get 1,000. So if I added 360 again, we get 1,000 degrees. B says 1,050, and we know that if we added 360 degrees one more time, we would go over 1,050, so we know that B would not be correct. So far we've got 640 degrees, that's coterminal, and notice that answer choices C and D are both negative angles, so we don't need to continue to add multiples of 360. That's not going to do us any good. So now let's take 280 degrees, and let's subtract multiples of 360. So if I take 280 degrees minus 360, that's going to give me negative 80 degrees. So negative 80 degrees is a coterminal angle. Well, that's answer choice C. Let's subtract 360 degrees again. So minus 360, that would give us negative 440 degrees. So that's a coterminal angle. However, D says negative 800, so let's go ahead and subtract 360 one more time. And we would get negative 800 degrees. So negative 800 degrees is another coterminal angle, so D is correct as well. So remember, you don't want to just add or subtract 360 degrees once. You need to do multiples of 360 degrees, adding or subtracting, to find out the different coterminal angles. Okay. Problem 11, which angle below is not a coterminal angle of 3 pi over 7? So same deal as number 10, but now we're working in radians. So instead of adding and subtracting multiples of 360 degrees, now we're going to add and subtract multiples of 2 pi radians. So we're going to take 3 pi over 7, and we're going to add and subtract 2 pi, or multiples of 2 pi radians. Now real quick, because we're dealing with fractions here, I'm going to represent 2 pi as 14 pi over 7. Just so that we have a common denominator to make the algebra easier here for us. So let's go ahead and start adding 2 pi, or 14 pi over 7. If I add 3 pi over 7 plus 14 pi over 7, that's going to give me 17 pi over 7. Okay, which is answer choice A. So we know we're not going to select answer choice A because we're looking for which one is not a coterminal angle. Let's go ahead and add 14 pi over 7 again. So adding 17 pi plus 14 pi, that's going to give us 31 pi over 7. So that's a coterminal angle, which is answer choice B. Notice that for answer choices C and D, we now have negative angles. So we don't need to continue to add 2 pi radians. Let's go ahead and start subtracting 2 pi radians. So now we're going to take 3 pi over 7, and we're going to start subtracting 14 pi over 7. This will give us negative 11 pi over 7. And if you look at your answer choices that are remaining, oh, that looks terrible. Let's try that again. Yeah, that's better. If you look at your answer choices remaining, answer choice C says negative 10 pi over 7. Well, we know that the coterminal angle is going to be negative 11 pi over 7, so this couldn't be correct. And just for example's sake, let's go ahead and look at answer choice D. If I subtracted 14 pi over 7 again, then we would end up getting negative 25 pi over 7, which would make answer choice D correct. Okay. Number 12. Which angles on the unit circle have a cosine of negative square root of 3 over 2? Notice it says which angles, and it says select all that applies, so there could be multiple angles. Well, let's take each one of these angles and just figure out what their cosines are. So the cosine of 30 degrees is square root of 3 over 2. Okay, but we want negative square root of 3 over 2, so that's not going to cut it. The cosine of 150 degrees is negative square root of 3 over 2. So we know this one's going to work. The cosine of 120 degrees is negative 1/2. So that's not going to work. The cosine of 330 degrees is square root of 3 over 2. Again, we want negative square root of 3 over 2, so that's not going to work. And the cosine of 210 degrees is negative square root of 3 over 2. So all these cosine values, I'm pulling off of the unit circle that we've already constructed. Also keep in mind that cosine of theta, the cosine of an angle, is equal to the x-coordinate. Okay? Looking at number 13. Which angles on the unit circle have a sine of negative 1/2? So doing something very similar. Again, remember that the sine of an angle is equal to the y-coordinate. So let's go through our unit circle. Let's check these angles and radians and see which ones have y-coordinates of negative 1/2. So if I look at 11 pi over 6, which is the same as 330 degrees, the sine is negative 1/2. So this one is going to check out. If I look at pi over 2, which is the same as 90 degrees, the sine is 1. If I look at 4 pi over 3, that's the same as 240 degrees, and the sine at 240 degrees, or 4 pi over 3, is negative square root of 3 over 2. If I look at 2 pi over 3, the sine is square root of 3 over 2. And finally, if I look at 7 pi over 6, the sine is negative 1/2, which is what we're looking for. So A and E are correct. B, C, and D do not have the correct signs. Or sorry, the correct sign values. All right, number 14. True or false? The cotangent is undefined at pi over 2 and 3 pi over 2. So if we look at pi over 2 and 3 pi over 2, well, at pi over 2, we have the coordinate 0, 1, and at 3 pi over 2, we have the coordinate 0, negative 1. So when we talk about the cotangent, remember that the cotangent is the cosine divided by the sine, because it's the reciprocal of the tangent. Well, cosine divided by sine, and let's go ahead and write that down here. Cotangent of an angle is equal to the cosine of that angle divided by the sine of that angle. Well, in the case of pi over 2, 0 divided by 1, that'd be cosine divided by sine, is 0, and the same thing holds true for 3 pi over 2. 0 divided by negative 1 is also 0. So 0 is not undefined. Undefined means you are dividing by 0. So this is actually false. It actually turns out at pi over 2 and 3 pi over 2 that the tangent is what is undefined at each of those angles. All right, and then lastly, last problem on this review, which statements below are true? Select all that apply. We're going to go through each one of these, okay? So statement A, the secant of both 60 degrees and 120 degrees is 2 root 3 over 3. Or sorry, the cosecant rather. So let's think about what the cosecant is. The cosecant is the reciprocal of sine, so 1 over the sine. So if I look at 60 degrees, the sine at 60 degrees is square root of 3 over 2. So if I did 1 over the square root of 3 over 2, because we want 1 over the sine, well, this would be 1 over 1 times 2 over square root of 3, which is 2 over square root of 3. Now again, we don't like having square roots in the denominator, so let's multiply both the numerator and the denominator by the square root of 3. And this is going to give us 2 square root of 3 over 3. So yes, the cosecant of 60 degrees is 2 square root of 3 over 3. Now let's check that same statement for 120 degrees. So at 120 degrees, notice that the sine value is also square root of 3 over 2. So since the sine is square root of 3 over 2 at 120 degrees also, the same exact math is going to apply. We're going to get 1 over the square root of 3 over 2, which is going to inevitably lead us to 2 square root of 3 over 3. So the cosecant of both 60 degrees and 120 degrees is in fact 2 square root of 3 over 3, after simplifying. Answer choice B says the tangent of 90 degrees is 0. Well, if we look at the tangent of 90 degrees, remember the tangent is sine over cosine. Well, the sine at 90 degrees is 1, the cosine at 90 degrees is 0, and 1 divided by 0 would be undefined. So this would actually be false. Answer choice C. The secant of both 3 pi over 4 and 5 pi over 4 is negative square root of 2. Well, recall that the secant is 1 over the cosine, because the secant is the reciprocal trig function for cosine. So let's look at 3 pi over 4 and 5 pi over 4, and let's look at their cosine values. So the cosine value of 3 pi over 4 is negative square root of 2 divided by 2. That's the cosine value. However, we want to take 1 over the cosine value, so we're going to do 1 over negative square root of 2 over 2. And this is going to be 1 over 1 times negative 2 over square root of 2, which would lead us to negative 2 over square root of 2. Again, we don't want square roots in the denominator. Let's go ahead and multiply both the numerator and denominator by the square root of 2. And this is going to give us negative 2 root 2 over 2. But one last thing, we notice that the 2's can reduce. So this simply gives us negative square root of 2. So for 3 pi over 4, this is definitely a true statement. Now let's look at 5 pi over 4. So 5 pi over 4 has a cosine value of negative square root of 2 over 2. So the exact same math is going to apply. We're going to get the exact same secant value since we do 1 over negative square root of 2 over 2. So C would be true as well. And again, that's because both 3 pi over 4 and 5 pi over 4 both have the same cosine value, which means they're both going to have the same secant value. All right, answer choice D. The cotangent of 330 degrees is negative square root of 3. So if we look at 330 degrees, that's root 3 over 2, comma, negative 1/2. That's the coordinate. And at this coordinate, remember that cotangent is the cosine divided by the sine. So I'm going to continue the work right over here. So cosine is square root of 3 over 2 divided by negative 1/2. This would be square root of 3 over 2 times negative 2 over 1. Notice that the 2's will end up reducing, and this is going to give us negative square root of 3 over 1, which is just negative square root of 3. So answer choice D is correct. And then lastly, answer choice E, the sine of an angle on the unit circle will always be negative in quadrant 2 and quadrant 3. However, if you look at quadrant 2 and quadrant 3, it's not the sine that's always negative, but it's actually the cosine that's always negative. So this would be false. Another way to look at it is that in quadrant 2, the sine is actually positive, while the sine is negative in quadrant 3.